Hi Falcons. What I'd like to talk to you about today is Lewis dot structures and how they're used to help us predict what an atom will do when forming a chemical bond. So to begin, we need to understand the concept of valence electrons. Valence electrons are the electrons in the outermost energy level of an atom. They're important because those outermost electrons are the ones that are used in chemical bonding, and as a result, they are the ones that determine the properties of each of the elements. As an example, this is neon. Neon is atomic number 10, meaning he has 10 protons and in a neutral atom 10 electrons. 2 electrons in the first energy level. The first energy level can only hold 2 electrons. In the second energy level, this would be its outermost energy level, and neon has 8 electrons in this outermost energy level. As a comparison, sodium is atomic number 11, meaning sodium would have 11 electrons total, but only one of them would be in its outermost energy level. So we would say that sodium has 1 valence electron. This is oxygen. Oxygen, like neon, has only 2 energy levels, but oxygen, whose atomic number is 8, has only 6 valence electrons, 6 electrons in its outermost energy level. Now, the most stable configuration for an element to have is a full outermost energy level, or full valence shell. For the most part, that would mean 8 electrons in the outermost energy level, hence what we refer to as the octet rule, or having 8 electrons in your outermost energy level, or valence shell. Noble gases, the elements in group 8A or 18, starting with helium and neon and working your way down, have this configuration. As a result, they are very stable and unreactive. Other elements will form chemical bonds to achieve this configuration. They will gain, lose, or share electrons to become like a noble gas and to have a full outermost energy level. Let's take a look at what this would be like for several elements on the periodic table. For example, oxygen and fluorine have 8 and 9 protons and 8 and 9 electrons respectively. But what this means in their outermost energy level is they are short of that 8 valence electrons that would make them stable. Oxygen with 6 valence electrons would be short 2. Fluorine with 7 valence electrons would be short 1. And as a result, they would seek to gain those electrons. Oxygen gaining 2 electrons, fluorine gaining 1 electron in order to become stable. Notice that they now have the same configuration as neon, or 8 valence electrons in the outermost shell. Conversely, sodium and magnesium, who have 3 energy levels and have only 1 or 2 electrons respectively in their outermost energy level. And therefore, because gaining 7 or gaining 6 valence electrons would be very difficult to do, they would find the easier path to give away these valence electrons in order to achieve the same configuration as neon. So sodium would like to give away 1 valence electron. Magnesium would like to give away 2 valence electrons. Sodium would then form a positive 1 ion, and magnesium would form a positive 2 ion, giving away 2 electrons to become stable. Now, to show these valence electrons in a simpler format, scientists will often write what is referred to as a Lewis dot structure. What that means is they'll simply write dots to account for just the valence electrons, just the electrons in the outermost shell. The way the periodic table is configured, all the elements in group 1, you would write 1 because they would all have 1 valence electron. So you would include 1 dot. In group 2, beginning with beryllium, these elements all have 2 valence electrons. So they would be represented with 2 dots in their Lewis dot structure. We would put them on opposite sides because electrons repel each other and they'd want to be as far apart as possible around the nucleus and inner electrons. You can see over here that in column 8, all of these noble gases have 8 valence electrons, the exception being helium, whose first energy level is filled with just 2. Notice that in group 7, these guys have 7 valence electrons. All the elements in the same column will have similar properties because all of those elements want to do the same thing in order to become stable. For example, all the elements in group 7A, fluorine, chlorine, bromine, iodine, would all want to gain 1 electron to become like a noble gas. All of the elements in group 6A would want to gain 2 to become like a noble gas, and so on and so forth. Let's go over a couple examples of how we would do this and predict the electron dot structure and ion formed by various elements in the periodic table. So let's say we were looking at magnesium. Magnesium is in group 2A. Therefore, magnesium would have 2 valence electrons. Magnesium would want to give those 2 valence electrons away to become like neon and form a positive 2 ion. Let's try as a counterexample an element, a nonmetal, from the right side of the periodic table. Let's look at chlorine. Chlorine would have 7 valence electrons. You would know this because chlorine is in group 7A. Chlorine would want to gain 1 electron to become like argon, forming a negative 1 ion, or what's referred to as an anion. Thanks. I hope this was helpful.